This is Algebra 1, Lesson 26, More Complicated Equations, examples 26.3 and 26.4. Here's a more complicated equation, and you can see that there are a lot more terms. So we're going to be able to use step 1. In the last video, we didn't have any like terms on the same side. So looking at this side, okay, I have 1, 2, 3, 4 terms. Let's see which of those are like terms. I have a 3x, and I have a minus x. Those are alike. And then I have a plus 2, that's a constant, and a plus 4. Let's put the 3x minus the x together. And I'm going to highlight that minus to remind us that that needs to go with it. 3x minus an x is like 3x minus 1x, which would be 2x's. Okay, don't write 3 there. It's 3x's minus 1x, which is 2x. Then I have a positive 2 plus positive 4, which would be plus 6 is equal to. Now let's go on the other side, and let's see if we can identify our terms. We have 1 term, 2 terms, 3 terms. Let's see which of those are like. I have a constant here, and I have a constant here. This variable has nothing like it. So let's combine our constants. Negative 5 minus 4. Okay, now I'm going to black something out for just a second. Ignore this for just a second. This is negative 5 minus 4. Don't get distracted or bothered by what's in the middle. Negative 5 minus 4 is like negative 5 plus a negative 4, which would be negative 9. So I'm going to write a negative 9 down. Then I bring down that term that didn't have anything else like it. Okay? We just accomplished step 1 on both sides. Okay? Step 2, eliminate the variable on one side. Now we learned in the last video that you can choose either side you want. So let me give you your options. Option A, you could subtract 2 x's from both sides. Or you could add x to both sides. Now I'm looking at the book. They chose to add x to both sides. That's what I would do. And let me tell you why I would choose that. I make less errors when I add than when I subtract, right? It's easier to add for me and probably for most of you. So you can subtract 2x from both sides if you want, but I'm going to choose to add x to both sides. Now that adding x cancels here, and it's 2x plus 1x here, so that's 3x plus 6 equals negative 9. I've accomplished step 2. Eliminate the constant term on the side with the variable. The side with the variable is here, the side of the equal sign, and here's your constant term that's on that side. So we need to get rid of it. What's the opposite of plus 6? It's subtracting 6. That's going to cancel here. We'll have 3x left. Negative 9 minus 6. That's like a negative 9 plus a negative 6, which is negative 15. I've accomplished step 3. Now I'm going to solve for the variable. I need to get rid of the 3. They're multiplying by it. So let's divide both sides by 3. X is equal to negative divided by positive is a negative. 15 divided by 3 is 5. Your solution is negative 5. And if you substituted that back in for all of these x's, you would get a true statement, a true equation. Here's example 26.4. Solve this equation. Let's look at the terms. Term, here's 1, here's 1, and here's 1. So 1, 2, 3, 4. What do we have that are like? Well, I have a k here, and I have a minus 4k here. And then constants, I have this plus 3 and this plus 7. Okay? Let's combine those. Let's do the variable first. 1k minus 4k's. 1 minus 4 is negative 3k's. Then I have the plus 3 plus 7, which would be plus 10. That's equal to Now let's look at the terms on the right side. I have two terms. Those two terms are not like terms, so I cannot combine them. I can't simplify, so let's just bring those down. Okay, and I've accomplished step 1. Let's look at step 2. Eliminate the variable on one side. All right, let's see what our options are. I could either get rid of the negative 3k by adding 3k, or I could get rid of the 2k by subtracting 2k. Which do you think would be the easier thing to do for this problem? Well, the book chose to add 3k to both sides. Why do you think they would do that? Well, it's like the last one. Most of us would make less errors when we're adding, so instead of subtracting 2k from both sides, they chose to add 3k to both sides. Now, you could certainly do it the other way. Okay, then I'm left with 10 is equal to 2k's plus 3k's is 5k minus 5. We have accomplished step 2. Eliminate the constant term on the side with the variable. The side of the equation of the equal sign, and the constant term is right here. So let's get rid of that. The opposite of minus 5 would be plus 5. That'll go away. Let's add 5 over here, and we get 15 is equal to 5k. Now we see they're multiplying by 5, so we're going to divide by 5. And we get 3 is equal to k. Forgot to check that off, and we just solved for the variable.